Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's explore what is Gateway API, why Gateway API, and most importantly, let's learn how to use Gateway API through some interesting demos. Especially for the demos, I prepared this GitHub repository. I'll share the link in the description. So after watching the video, if you are interested in demos, you can head to this repo and use the manifest that I'm going to use in the video. Perfect. Let's get started. Now, personally, I believe whenever you want to learn something, you should start with the why aspect. In this case, why Gateway API? I mean, when you have something like Ingress in Kubernetes, why should you migrate to Gateway API? What are the drawbacks with Ingress? Let's start with understanding from this point of view. So to understand this better, let's go few years back in time when Kubernetes started as container orchestration engine. So we all know Kubernetes solved major problems with containers. So a lot of companies started using Kubernetes as their deployment platform. So companies started deploying their microservices. It can be their login service, product service, payment service, etc. For Kubernetes, east-west traffic was never a problem. I mean, service to service communication within a Kubernetes cluster was never a problem because Kubernetes has a network which is in cluster network. But the major challenge for Kubernetes was the north-south traffic. That is, how to enable external users access pods within Kubernetes. For example, how an external user creates an account with login service of a platform. It's a very important workflow, right? Without external users accessing the login microservice, the platform that is deployed to Kubernetes is of no use. And this was challenging for Kubernetes because Kubernetes did not have, even today it does not have, a native load balancer component. Just like how Kubernetes has API controller, scheduler, etcd, it does not have a load balancer component. And I believe this was an intentional decision by Kubernetes. Anyways, Kubernetes has to solve this problem. So Kubernetes said, we will introduce a concept called Ingress. So basically, there are multiple load balancing companies on the internet. For example, Nginx, HA proxy, even cloud providers like AWS, they all have load balancers and they have very popular load balancers. So Kubernetes said these companies, if you want to support load balancing with Kubernetes, you should develop an Ingress controller, right? Once these companies have the Ingress controller, the steps are very simple. Platform engineer or the cluster administrator should deploy Ingress controller to the cluster, right? This is a one-time activity. It can be complete cluster scoped. And then DevOps engineer, whichever service they want to expose. Let's say DevOps engineer wants to expose login microservice. So DevOps engineer creates an Ingress resource like this, where in the kind Ingress, DevOps engineer provides the login service configuration and provides the path on which login service should be accessed. Once this Ingress resource is created, Ingress controller watches the Ingress resource and according to the configuration, it creates a load balancer. Now you all know, once a load balancer is created, problem is solved because load balancer can be public facing. Using this load balancer, external user talks to the load balancer routes the request to the relevant service in Kubernetes. This is how Kubernetes solved the problem with north-south traffic. So it used the concept of Ingress. Now this was a magic bullet at that point of time because now Kubernetes was able to solve east-west traffic and north-south traffic as well. However, it only took few years for the Kubernetes users to realize there are some major drawbacks with Ingress. In this video, I'll cover two important drawbacks. Drawback number one, which is very important, is the limited scope of Ingress. What does that mean? You know, if you look at Ingress resource one more time, as I told you, there are only two things that you can mention in the Ingress specification. One, the service which should be exposed to the load balancer. Two, the path on which the service should be accessed to the end user or accessible to the end user. So typically, I mean, if I have to put this in a sentence, through Ingress resource, Kubernetes can tell the load balancer, allow requests to the login microservice only if the user access the service on the path /login. Okay. So if user hits a request on /login, forward the request to login pods deployed on the Kubernetes cluster. This is all what can be conveyed using the Ingress resource. Now this is pretty basic, right? In today's world, just exposing service using the load balancer is not enough. In today's world, people need things like rate limiting. People need things like web application firewall. People need HTTP redirect. They need canary model of deployment, right? Even basic things like denial of service attack prevention, right? Rewrite URL, etc. So these have become mandatory for the production level workloads in today's world. But unfortunately, Kubernetes spec, that is the Ingress spec, does not support any of them. We can even take an example, right? Because this is very important to understand. Let's take an example and try to understand one more time. Let's say there is an organization. This organization is on AWS ecosystem. So the platform engineer or the cluster administrator, they installed ALB controller, which is the Ingress controller. Now the DevOps engineer of a service, let's say the login service itself, created an Ingress resource with spec, where the DevOps engineer defined, okay, login service should be exposed to internet on path /login. Ingress controller watched this specification and it created a load balancer. Okay, the end users were happy because through the load balancer, they can access the login microservice. But after few days, DevOps engineer said, along with this, I want to implement canary model of deployment. It is mandatory in our organization. So I want to go with canary model of deployment. Or I want to go with web application firewall. Unfortunately, this is not supported in the Ingress spec. That is what I'm trying to convey. However, you should note here, it's not the drawback with the load balancer. Today, you take any load balancer, they support basic features like web application firewall, right? They can integrate with WAF. The problem here is with the Ingress specification. So that's why the load balancer companies or the Ingress controller said, okay, this is the problem with Ingress spec. So we will work around. What we will do, we will also support annotations, right? So Nginx Ingress controller, ALB Ingress controller, traffic controller, ALB controller, all the Ingress controllers started supporting annotations because the spec was limited. Now you might say, okay, Abhishek, then the problem is solved because whatever can be defined in the spec, DevOps engineers will do it. Additional thing, they will define using the Kubernetes annotations. Now, initially, the problem looked to be solved, but this only added additional complexity. Let me explain. One, the number of annotations grew exponentially. For example, if you go to ALB controller documentation, you can go to any Ingress controller documentation. Just go to the guide, look at Ingress, click on the annotation. You will notice there are huge number of annotations. Look at the count here, right? There are almost 30 to 40 annotations. So every time DevOps engineer has to go through this documentation, and this can keep changing as well, right? For ALB controller, these are the annotations. For Nginx controller, the annotations can be different. For traffic, again, the annotations can be different. This is one challenge. On top of that, if you look at the Ingress resource now, okay, you might say, Abhishek, DevOps engineer can go through the ALB controller documentation and add web application firewall. So the load balancer will be created with WAF. This is exactly true, but what should look like a simple Ingress resource? No, this is the expectation, but the reality is that Ingress resources started looking very, very complex. For example, this is how a production grade Ingress resource started to look like. Look at the annotations. The specification is very simple, but annotations are very, very complex. In fact, I have to just keep scrolling right to complete the annotation definition. This is the annotation. Okay, I'll just copy it and paste it here for you so that you can read the annotation. Okay, let's break it. So, I'll just break it down further, further, only then you will be able to read the annotation. So this is a single annotation that DevOps engineer should add to implement weight-based routing. This is a JSON that DevOps engineer has to define in the Kubernetes YAML file. This is just one annotation. Imagine 20 such annotations. The readability is gone, complexity has increased. On top of that, the learning curve is also steep. Why? This is just the annotation for ALB controller. Tomorrow, if you move to a different Ingress controller, the annotation can change. Because of all of these reasons, this is considered as a drawback. One more time, Kubernetes Ingress spec is very limited, right? All that it can say, which service should be exposed, on which path the service should be exposed. It cannot implement rate limiting. It cannot implement web application firewall, canary deployment, DDoS. Natively, it cannot implement any production grade features. But the Ingress controllers, they worked around, it was a partial workaround where they started supporting annotations. But it looked like a temporary solution. It became very complicated for DevOps engineers because these annotations are defined in the JSON format and they keep changing from controller to controller. So the learning curve became steep for the DevOps engineers. This is the first drawback. Now let's talk about the second drawback. The second drawback is that, of course, this is not for every company, but some companies reported they have platform engineers within the company and they have DevOps engineers within the company. And both the platform engineers as well as DevOps engineers are updating the same Ingress file. Let me explain. So in some companies, the Ingress class name is maintained by platform engineers because platform engineers are the cluster administrators. They take care of installing the Ingress controller and they were defining the Ingress class name within the Ingress resource. And rest of the fields are maintained by the DevOps engineers. So there is no clear separation of access. Both of them are updating the Ingress resource. So there is a possibility that DevOps engineers can update the Ingress class name, which might mess up with platform engineers' expected configuration, right? So because both of them are using the same resource, both of them have the right access to same resource, they might mess up with each other's configuration. In a nutshell, companies have requested for clear access separation. How? By breaking down Ingress into two parts. Break down Ingress class name as a different resource and break down the rest of the Ingress into a different resource. Of course, Kubernetes did not implement this because it becomes a major breaking change. For addressing both of these drawbacks, which were there in the community for a long time now, Kubernetes decided, okay, these are pending requests and a lot of people have been asking for this. So let's come up with Gateway API. So this is how Gateway API came into picture. It's not that Gateway API is solving a different problem. It is solving the same problem that Ingress solved, the problem with north-south traffic. But Gateway API is trying to solve the problem by addressing the drawbacks of Ingress. Whatever drawbacks we discussed, right? But Abhishek, how Gateway API plans to, or how Gateway API is solving these problems? Basically, the first thing Kubernetes community did. So instead of providing Gateway API as a single resource, they broke down this into three different resources. The first one is the Gateway API class, right? Or you can call it as Gateway class. Second resource is the Gateway resource. And third resource is the HTTP route resource. Now, all three of them are custom resources, which is an added advantage. Previously, Ingress was a native resource, but in this case, the gateway API resources are CRDs. So it is very easy for the open source community to update these CRDs and maintain these resources. Anyways, going back, these are the three resources that Gateway API introduced. Now, what exactly are these resources? The first one is the gateway class resource. Whenever the platform engineer creates a gateway controller, just like Ingress controller, this time the gateway controller, it can be Nginx gateway controller, it can be traffic gateway controller. When they install this controller, they will create a gateway class resource. And these two resources are created by DevOps engineers or the application admins. This resource, the gateway resource, defines which gateway class to be used. And this resource defines the backend service configuration. That is, on which port the service should be accessed, on which path the service should be accessed. In fact, everything that we discussed, like web application firewall support, HTTP redirect support, traffic splitting support, canary model of deployment, everything is supported by HTTP route. One more time, gateway class is defined by cluster administrators. When they install a gateway controller similar to Ingress controller, they create a gateway class. Then these two resources are defined by the DevOps engineers. They first create a gateway resource, which explicitly defines which gateway controller to use. And then they define HTTP route, where they provide the service configuration and the features that they need with the load balancer. Now you might ask, Abhishek, how this is solving the problems with Ingress? As I told you, HTTP route is now very capable of implementing production grade features. So the drawback one is complete. Instead of huge annotations, anyways, I'll show you in the demo, but let's say the DevOps engineer wants to implement same weight-based deployment. Now DevOps engineer don't have to add that complicated annotation, but just should add the weight field. So weight is 2, weight is 8. That means 80% of traffic goes to this service and 20% of this traffic goes to the other service. All that complex annotation is now replaced with a single field. So the drawback one is addressed. Now drawback two, there is a clear separation, right? The gateway class is maintained by the cluster administrators. Gateway and HTTP route is maintained by the DevOps engineers. Even the clear separation that community was asking for is also provided. This is how Gateway API is addressing the challenges with Ingress. One more time, Gateway API is not anything new. It is solving the same problem that Ingress was solving, but it is solving the same problem by addressing the drawbacks with Ingress. Now that the concept of Gateway API is clear, let's move to the practicals. So I'll show you through demos how you can use Gateway API in real time. I'll take a sample application and I'll show you how for a sample application, instead of Ingress, now we will use Gateway class, Gateway and HTTP route. So let's start with the first step. The cluster administrator creates a Kubernetes cluster. In my case, I'll use kind create cluster hyphen name. I'll provide the name of the cluster. Let me call it as GW demo cluster. If you want, you can go with Minikube or you can even go with Micro K8s or any other local distribution. Perfect. Now that the cluster is created, let's go with the first step, that is to install Gateway API CRDs and install Envoy Gateway Controller. I'm not using Nginx Gateway Controller in this case because Envoy Gateway Controller is much stable and it is also very beginner friendly. So if you want to learn Gateway API Controller, the concept of Gateway API, make sure you start with Envoy. Cool. So how do we install Gateway API CRDs and Envoy Gateway? Don't worry, all the steps are documented. So first, we will clone this GitHub repo. Let's do that. Git clone followed by the repository URL. Now switch to the directory Gateway API. If you just list the folders here, you will find all the folders in order 00, 01, 02, 03, and 04. Just go with the same order. Now to install Gateway API and Envoy controller, switch to 00 install. Here you will find a README file. Open the README file. There is a Helm command which will do all of that. Whatever we are talking about, simple Helm command does all of that for us. Let's break down the Helm command. So the Helm command is first creating the namespace, right? So it's creating a namespace called Envoy Gateway System. And within this namespace, it is installing this chart. Now, what does this chart have? So this chart has the Gateway API CRDs as well as Envoy Gateway related deployment as well as service. We can verify. First, I'll see what is inside the namespace. kubectl get pods -n Envoy Gateway System. Okay. So you can see the controller here. This is just like, again, this is just like Ingress controller. Ingress controller usually waits for the Ingress resource. And here, Gateway controller waits for the gateway as well as HTTP route resource. If you want, you can also look at the logs of it. kubectl logs, provide the name of the pod and the namespace. In this case, Envoy Gateway System namespace. At this point, it does not have any gateway or HTTP resource. So it is just waiting for the resources to be created. No accepted gateway class, no gateways yet, no HTTP resources yet. Cool. We will also look at the CRDs. kubectl get CRDs -a. So you can see we have the gateway class CRD created. We have gateway CRD created, even HTTP route CRD created. So our step 1 is done. Now let's move to step 2. What is step 2? because the platform engineer job is almost done. They have set up cluster, they have set up cluster resources. Now it's turn of DevOps engineer to install application first, right? Even before creating the resources like no HTTP route or gateway, you need application. To expose application, you need to create an application, right? So those steps are provided in the 01 basic install folder. Okay, go to the previous folder 01 basic deploy. If you just do ls, you will find service account.yaml, deployment.yaml, and service.yaml. These three files will create the deployment for us. We will start with creating the service account, kubectl apply-f service account.yaml. Someone asked me, why is this service account required? Very simple. If you don't use the service account, deployment will use the default service account of the namespace. But it is always good practice to create your service account and use the deployment with this service account. Now I'll run the deployment kubectl apply-f deploy.yaml. Okay, let's see if the pods are running. Kubectl get pods. Container is still creating. Let's watch. There you go. Now the application is also running. Finally, let's create service for the application. What is this service doing? Nothing. It is just exposing the application on port 3000 within the cluster. Because we are using service of type cluster IP, it will be restricted to the cluster and it will allow other pods to access the service on the port 3000. Let's do that. kubectl apply-f service.yaml. Now I'm sure you must be curious, Abhishek, what exactly is this application, right? What application are we actually working on? We are working on basic ping pong application. Now, whenever someone sends a request to it, it will just return back with the request details. Let me show you. Now, because we are using a local cluster, we can log into the cluster and send request to the service. I'm using kind, so I'll just log into the Docker container. In kind, the entire cluster is running within this Docker container. If you are using Minikube, just run Minikube SSH. Cool. Docker exec -it followed by container ID followed by /bin/bash. Before you press on enter, copy the cluster IP of the service. Cool. Enter. Now we'll verify the behavior of the application. Let's send a dummy request. Curl HTTP or just provide the IP address of the service followed by port 3000. Okay, there you go. So you send a request, see what is the response. So the response is very basic. It says, okay, someone tried to access me on path/. This is their host details. They use the get method. They used no headers. I mean, there are no headers in the request, in the curl request. And then this is the namespace from which they try to access. This is the pod which they try to access. Basic information, right? And this is good enough for our demonstration. I'll log out from the cluster. And now let's go to the next steps. Now that our application is running, let's expose it to external world. For that, we need the gateway class, we need gateway, and we need http.yaml. When you're dealing with Ingress, you just need one thing, that is ingress.yaml. Anyways, okay. So first of all, we should deploy gateway class.yaml. In fact, in many companies, that will be done by platform engineer. Whenever platform engineer creates envoy gateway, at the same time, they create this gateway class. Very simple. kubectl apply-f gateway.gateway gateway class.yaml. But Abhishek, what is inside this gateway class? Let's see. If we just open the gateway class.yaml, it just says that anybody who's using this gateway class, this will be read by the envoy proxy, or anyone who is using the gateway class, they are indirectly using the envoy proxy gateway. But who is using this gateway class? We know this will be used by our HTTP route as well as our gateway service. Let's start with creating the gateway. Of course, first I'll show you the gateway. What exactly is written inside the gateway resource? Kind is gateway. You don't have to change it. These are the important fields. First of all, you will define that you want to use envoy gateway proxy, right? Without this field, your gateway does not understand which controller it has to use or which controller should read this resource. That's why, just like you provide Ingress class name, in the gateway, you have to provide gateway class name. This tells this gateway resource will be read by the envoy proxy. And then you are providing listener information. This is basically to say load balancer, the one that will be created, should listen on the port 80. Okay, perfect. We created the gateway class. Now it's time to create the most important resource, that is HTTP route. Why did I say this is the most important resource? Because this is where you provide your backend configuration. So you are saying my backend reference is a service. So the request from the load balancer should go to this service and should go to 3000 port of the service. On top of that, you are also saying here the request should only be accepted if user is using the hostname www.example.com, right? So when a user requests the load balancer, when user access the load balancer on host example.com and provides the path slash request goes to the service on the port 3000, right? I'll try to explain this here to you so that things are very clear. What is this HTTP route doing? So first, gateway will create a load balancer, right? Load balancer is listening on port 80. Now this HTTP route says anyone who requests the load balancer on example.com, right? The request should go to the service. The name of the service is the backend service, and it should forward the request. Load balancer should forward the request on port 3000. Perfect. So let's run this as well. kubectl apply-f http route.yaml. That's it. Now this should have all the configuration for us. Now if you see kubectl get pods -n envoy gateway system. So here envoy default, this is the load balancer that is created for us. Of course, we are dealing with envoy. So this is the proxy that is created for us. Now you can send the request to this proxy. This will act as a load balancer for us. And from this request or from this proxy, request will be forwarded to the service. If you're dealing with ALB, that is if you're dealing with Amazon or if you're dealing with any other load balancers, it will create an external load balancer for you. Because we are dealing with envoy, a proxy or a reverse proxy is set up for us. Cool. So now if I do kubectl get svc in the same namespace, there should be a service created for this proxy. Let's do that. Okay. So the service is also created for us and the service is of type load balancer. Of course, in our case, we are using kind cluster. So load balancer service type won't work. What I will do instead, I will run kubectl port forward svc followed by name of the svc, right? And I will tie the port. The service port is 80 I'll use my local port 9090 colon service port, and I will say address 0.0.0.0. I forgot the namespace. Let me also provide that. Hyphen N envoy gateway system. So basically, because my local cluster does not support load balancer service type, I'm using kubectl port forward to expose the service. Okay, now the load balancer is exposed. Now anyone who tries to access the load balancer, it should serve. They just have to access it on port 9090. Localhost 9090. Let's keep this session. I'll take a new session so that I don't close the port forwarding. Duplicate session, and here I will use the curl command. Okay, what is the curl command? Curl hyphen hyphen verbose. I'm using the header where I'm passing the host name as www.example.com, the one that we used in the gateway or the HTTP resource. And then I'm forwarding the request, or I'm making the request to HTTP localhost port 9090. Okay, one more time. I'll show the request for you. The request that I executed, curl, I'm using this as the host, and I'm sending the request to HTTP localhost 9090. When I click on enter, this is the response. What does that mean? That means now the request was sent to this load balancer or the reverse proxy. From there, request went to the HTTP route, and from there, request went to the pod. You can see the same thing, right? It clearly says user sent a request to example.com and request is sent to this backend pod. So this backend pod is serving the request. So this is how gateway is used in real time. I hope this part of the demo is clear. This is very basic installation. Till now, we created an application. We created gateway class for it. We created gateway resource, which explains which gateway controller should be used. In our case, envoy gateway controller. And then we define basic HTTP route. Cool. Now let's head to the next step. Okay. I'll go back to the previous folder. Now we will install, or we will set up URL rewrite. What is URL rewrite? Basically, this is advanced capability where you send a request to the load balancer. For example, you send request to slash origin slash get slash path. But the load balancer should rewrite your URL and forward the request to, let's say, slash origin slash replace slash path. So this feature is what we call as URL rewrite. You are actually sending request to a particular path, but load balancer is forwarding the request to a different path. This is used when your application endpoint changed. You don't want end users to face trouble. So you can implement rewrite URLs in the load balancer. Let's see how this is done. It's very simple. You don't have to change the application. You don't have to change anything in the gateway. Only thing that you have to change is in the HTTP resource, right? So now our HTTP resource will be changed. So something like this. I'm intentionally using a different hostname so that your first demonstration will not be disturbed. I'll keep the first demonstration as is. In the second demonstration, I'm using a different hostname so that the load balancer does not get confused. What you have to focus is this part. So here in the rules, you can see if someone sends request to slash get, change the request to slash replace. Okay. If you find slash get in the URL, change that to slash replace. That's what we are defining using this filter URL rewrite. But Abhishek, how do you know this has to be the configuration? Don't worry. Not only me, anyone cannot remember this. You just have to go through the official documentation. So this is the official Envoy Gateway documentation. Even I went to this, I went to the traffic and I looked at URL rewrite example. In fact, I'm just using a modified version of that example. Cool? Okay. Because a lot of people get confused. How do I remember these things? You don't have to remember this because there is no point in remembering these things. Cool. So I'll save this file. Okay. Now let's execute this file. kubectl apply-f rewrite http route.yaml. Cool. Now let's see. You know, now this time I will send the request to our new host. What is our new host? Let's again get the host name. So the host name is path.rewrite.example. Okay. Curl hyphen l hyphen verbose. Now this time in the header, I'm passing the host name as path.rewrite.example. Then I'm sending the request to http localhost. The port name is wrong. In my case, the port name is 9090. I'm sending the request to get origin path extra. This should change to replace origin path extra. Let's see. If I run this command, what happened? Now I executed the command. Request went to the load balancer. Request is accepted. You can see the request is accepted. HTTP response is 200. And if you notice carefully, this request here /get/origin path extra is changed to /replace origin path extra. So wherever there is get, it rewrote the URL to /replace. Who changed this? This is changed by the load balancer. In our case, the Envoy Gateway proxy. But Abhishek, why are we passing this host name all the time? This is because we are not tying the load balancer DNS name with this particular host. In real time, you don't have to pass this host name because the load balancer will be tied with this DNS name. Something like path.amazon.com or something like payments.amazon.com, right? So you don't have to provide the host name in real time. Cool. So this is also done. We verified how rewrite URL can be implemented. Now let's try something even more interesting. Let's try traffic splitting. What is traffic splitting? In real time, when you are working with applications, you might deploy a new version of the application and you want to send 50% of the traffic to the old version, 50% of the traffic to the new version, right? When you are dealing with production critical workloads. So previously you have, let's say, version 1 of the application, load balancer is pointing to it, 100% of the traffic is going to it. Then you have deployed version 2. Now you're not very confident about it. So you want to send 50% traffic to version 2 and 50% traffic to version 1. Once you are confident, you can remove this and you can send 100% traffic to version 2, right? How to implement this? This feature is called traffic splitting. And to implement this, let's go to 03 folder. And here we will first install a new backend. Of course, we need version 2, right? Right? To send requests to two different versions of application. We already installed version 1 here. If I do kubectl get all, you will see the backend related pods, which are version 1. Now to install version 2, go to the backend2 folder, which I am already here, and run the same things. kubectl apply-f service account.yaml. Okay, service account is created. Now kubectl apply-f deploy.yaml. Okay, finally kubectl apply-f service.yaml. There you go. Now our service is also created. Now if I just do kubectl get all, you should see both service 1 and service 2. So this is service 1, this is service 2. This is service 1, this is service 2. Okay, this is service 1, this is service 2. Cool. Now we deployed all the configuration. Once again, we don't have to change anything in the gateway. So gateway is created only once because it just has configuration, the listener of the load balancer, and gateway class we want to use. So we can keep it the same. We will only focus on changing HTTP route again. Let's see what is in it. HTTP route splitting.yaml. So in the backend reference, this time we will provide both the service configuration. Previously in the backend reference, we just provided kind as service, name as backend, port as 3000. This time, just provide service backend 2. So in backend reference, provide service 1 and service 2. That's it. HTTP route will configure the load balancer in the same way. It will send 50% traffic to this, 50% traffic to this. Again, let's see. Okay, kubectl apply -f HTTP route traffic splitting.yaml. What is our host this time? So this time our host is backends.example. Correct? Okay. So let's send the curl request again. Curl followed by I'll use the verbose. Then I'll pass the header host, sorry, hyphen header, and within the header I'll pass the host. What is our host? Backends.example. Right? I hope this is what we used. Followed by HTTP localhost colon 9090 slash, we will just pass the pass as get. Okay, let's see. Cool. I'll remove the verbose to make the output look very simple because we want to verify traffic splitting. One time request going to backend 1, other time request going to backend 2. Okay, so let's see. I sent the request. Request went to backend 2. Okay, I'll send the request again. Clear. Enter. You can see request went to backend 1. Let's do it again. Okay, request went to backend. Now let's try again. Request went to backend. Try again. Request went to backend 2. So this way, 50% of the traffic again it went to backend 2. So it does not mean, once it goes to backend, second time it goes to backend 2. Overall, 50% of the traffic will go to backend. 50% of the traffic will go to backend 2. Like if you take average of 100 requests, you will see 50 requests to backend, 50 requests to backend 2. This is what we call as traffic splitting. This is not round robin. Remember, round robin is one request goes to backend 1, one request goes to backend 2. But in traffic splitting, overall, 50% of the traffic goes to one, 50% of traffic goes to the other one. Cool. So we learned traffic splitting as well. Now, but Abhishek, instead of 50-50, I want to send 80% traffic to backend 1 and 20% traffic to backend 2. Is that possible? Definitely yes. We will call it as weight-based load balancing. This is also very similar to canary model of deployment because almost the same concept where we will send X% request to one service, Y% request to other service. Let's see how to achieve that. So we will go to 04 weighted. Here, all that we have to do is to again change just HTTP route file. Okay. Basically, I can change the same HTTP route itself, but for your reference, I want to provide a GitHub repository so that you can go back and try. That's why I'm not modifying the same file again and again, but I'm reusing the files. I'm creating new files. Cool. So this time, it's exactly the same as previous one where we provided service 1 configuration, service 2 configuration. Only change is that here we added the weight. So for service 1, I'm calling the weight as 8. For service 2, I'm calling the weight as 2. That means 80% goes here, 20% goes here. Compare the difference. If I compare this with vim hyphen hyphen 03, right? And if I show you the traffic splitting file, it's the same thing, but here the wait keyword is missing or the wait field is missing. Whereas if you go to our HTTP route for waited, there is wait field in this particular YAML file. That's all. This is the difference between traffic splitting and implementing wait based load balancing. Cool. Let's run this and see if 80% request goes there. Okay. So I'll do kubectl apply hyphen f HTTP route wait based wait.yaml. Okay. Even in this case, the host name that we used is backends.example. We did not change the host name this time. Let's verify. So I'll run the same curl command, curl backends.example localhost 9090 get. Okay, let's count it. Once request went to backend 2 out of 10 times. Let's take average of 10 times. Our goal is that 2 requests should go to backend 2, 8 requests should go to backend 1. Okay, already 1 request went. Second time, okay, only once request went to backend 2. Third time, again it's backend 1, so only request went once to backend 2. Fourth time, again backend 1. Fifth time, again backend 1. Sixth time, backend 1. Seventh, eighth, ninth, and finally 10th time. Okay, you might say, Abhishek, but it is expected to go 2 times out of the 10 times. Very simple logic. As I told you, you should take a higher average. Like for example, 14th time request went to backend 2. So overall, if you take 100 requests, 80% request goes to backend 1, 20% request goes to backend 2. It's not that you take 10 requests and you expect 2 requests go to backend 2. You should take a bigger number and verify 20% out of it. Cool. So this is all how you implement Gateway API in real time. I'll be very honest with you. For the first time, you will find this concept overwhelming. It's not that you are a beginner in the world of Kubernetes, or it's not that you get this concept. The concept itself is little complex because we are moving from the world of Ingress. Let's say if you have implemented Istio or any other controller similar, the service mesh concept, you will find it little easy. Otherwise, I totally get it. The concept is not that easy to grasp for the very first time. So that's why after watching this video, you should go ahead and practice things. If you don't practice this, down the line, maybe in the next 1 week, you will forget everything. Cool. That's why I prepared the GitHub repository. Please make sure you go through the GitHub repo. I don't want my effort and your effort of watching this video to go wasted. For mutual benefit, please try the demos that I provided in the GitHub repo. Thank you so much for watching today's video. See you all in the next one. Take care.